Alright guys, your essential question for today is how do we calculate the areas of triangles? Now I know that from middle school, one of the main area formulas that you remember is the area of a triangle is 1/2 the base times the height. Now for the most part though guys, it's kind of confines you to a certain type of triangle, basically a right triangle where this is your height and this is your base. If you knew those two dimensions, then you could do 1/2 base times height to find the area of the triangle. Or even if you had a non-right triangle, if you knew the height of that triangle, you could still do 1/2 base times height. Well, what we're going to be looking at is any kind of triangle. And so, like, let's say you didn't know what the length of the height is or the base is, could you still find the area of that triangle? Thankfully, you'll be happy to know that there are just formulas that you just basically have to memorize to help you work out these problems. Just remember, you will have a quiz over this material and a test over this material at a later date. All right, I'm just going to go ahead and jump right into it and give you a second to look at the three specific formulas we're going to be using for today's lesson. It says, let triangle ABC be any triangle with lowercase ABC representing the measures of the sides, with opposite angles with measurements capital A, B, and C, respectively. Then the area, we're just going to call it K, since we don't use A since we've already got the letter A there. We're just going to use the letter K. The area K can be determined using one of the following formulas. Now, you have to determine which formula you're going to use. So, if you have two sides and the included angle, you're going to use this formula. The area is 1/2 AB times sine of C. If you are given two angles and a side, you're going to use this formula. 1/2 A squared sine B sine C over sine A. Now notice that whatever side you're given, make sure that the angle of that side is in the denominator. So you notice this is A squared. Notice where sine of A is. It's in the denominator. The other two are up there. Finally, if you're given all three sides, you're going to use something called Heron's formula, which is the square root of S times S minus A, S minus B, S minus C. Now, A, B, and C obviously are your sides. Where S comes into play is, S is what we call the semi-perimeter, and how you find the semi-perimeter is you add up all three sides and divide it by 2, and so that's the semi-perimeter. So depending on what situation you have, dictates what formula you use. Now, on the next slide, I'm going to have all the formulas, and we're going to determine which formula to use for what. All right, so here are all three formulas, and for the first one, it says in triangle RST, S is 12, T is 4, and angle R is 37. So what I'm going to do is I'm just going to go ahead and get an idea of what this looks like. So RST, S is 12, T is 4, and angle R is 37 degrees. Well, which one of these three situations does this represent? Well, I got two sides and the included angle, so that would be this one. So my area is simply going to be 1/2 A times B, and it doesn't matter which one you put first, 412, times sine of the angle. Not bad, right? So all we're going to do is literally type this into our calculator. So 1/2 4 times 12 times sine of 37, and that'll give me 14.4, and I'm just going to say units squared, because I don't know if that's centimeters or inches or whatever, but that would be the area of that triangle. Okay? Not bad. All right, let's try the next one. Number 2, in triangle BCA, so BCA, A is 5, so there's 5, C is 12, so that's 12, and angle B is 38 degrees. Again, which situation does this represent? Well, included angle, two sides. So I'm going to use the formula 1/2 AB sine of C, so in this case it will be 1/2 times 5 times 12 times 38 degrees. So again, I'm going to do 1/2 times 5 times 12 times sine of 38 degrees, and that's going to give me 18.5 units squared, or it could be inches squared or whatever. Alright, so not bad, not bad. Alright, let's try another one. Alright, for example 3, let's see what I've got. A triangle STR. So STR, it says angle R is 69 degrees. I'm sorry, angle S is 69 degrees, angle T is 77 degrees, and side S is 9. Alright, so notice that I'm given two angles and a side. Well, the first thing I'm going to do, I notice that two angles aside, I know I'm going to use this formula, but notice in the formula I need to know what all three angles are. So the first thing I'm going to do is I'm going to add the 77 plus the 69, and I'm going to subtract that from 180, and that's going to give me 34 degrees for angle R. Now the reason why that's important is because in the formula, guys, whatever side you are given, make sure that that angle goes in the denominator. So since I'm given side S is 9, I'm going to make sure that angle S, or 69 degrees, is going to be in the denominator. All right, so my area is going to be 1/2 9 squared times sine of 77 times sine of 34 divided by sine of 69. Now, it doesn't matter which order you put the sine of 77 and the sine of 34 in, you'll still get the same answer. But if I do this and type it into my calculator, I'll end up getting 23.6 units squared. So that would be the area for this triangle. And then let's try number 4. It says in triangle XYZ, so XYZ, it says angle Y is 105 degrees, X is 14, and angle X is 45 degrees. So this also is this situation. So the first thing I'm going to do is add up my two angles and subtract it from 180. That's going to give me 30. And then I'm going to pair up the side with its angle, the only side I'm given, and make sure that I use that in the formula. So my area is going to be 1/2 14 squared sine of 105 times sine of 30 divided by sine of 45. And my 105 doesn't look very neat, so I'm just going to rewrite that 105. Alright, and so if I do this in my calculator and type all of this information in, then I should get 66.9 units squared. And then that would be the correct answer for that one as well. Alright, let's look at two more. Obviously two more because that's the last example we're going to try. For number 5, whoops, let me move it over here. For number 5, it says an triangle STR. So notice I'm given R is 4, T is 9, and S is 6. I'm not given any angle. So I know I'm going to be using the last formula. For the last formula, the first thing I'm going to do is find my semi-perimeter, which is 1/2 plus 4 plus 6 plus 9. Well, 4 plus 6 is 10. 10 plus 9 is 19. So then that's going to give me 9.5 as my semi-perimeter. And so my formula is going to be the square root of 9.5 times 9.5 minus 4 times 9.5 minus 6 times 9.5 minus 9. So the main issue with this calculator is this formula is the fact that it takes a lot of typing. But just like the other two formulas, once you got it in there, it works pretty well, and I'm going to get 9.6 units squared for that one. Alright, for the last one, number 6, it's got triangle QRP. So it says side R is 7, side P is 14, and side Q is 8. So again, I'm given 3 sides. So the first thing I'm going to do is find my semi-perimeter by adding up all 3 sides. So 14 plus 8 plus 7 and divide that by 2 gives me 14.5. So to find my area, I'm simply going to do 14.5 times 14.5 minus 14 times 14.5 minus 8 times 14.5 minus 7. And so then that would give me my area for this particular situation. And again, guys, it does take just a little bit of time to type all this in, but once you do so, I would get an answer of about 18.8 units squared. Alright, that's the end for today's lesson.